Let's quickly go over how you can use multi-threading on your Scuttle robot to improve the performance of execution of different tasks. So we'll start with an example. I want to execute two main programs, each of which has a level 3 software to run. On the left hand here, I want to collect commands from the gamepad and perform closed-loop speed control. This program needs to execute at least 5 times per second in order to have smooth driving performance. On the second program, I want to have my robot evaluate its current heading and speak out loud to tell the heading to the user via voice to text. So basically, I have the encoders telling me the movement of my wheels. I have the gamepad information captured on this column and passing commands to the level 3. And then the information gets crunched and sent to the speed control to give the target wheel speeds, which eventually reach the motors. On the second program, I have the MPU sensor that's on board the BeagleBone that's getting its values sampled from the Compass driver in the RCPY library. The level 2 program called L2 heading is computing the heading of the robot from those Compass values, and then the information is getting converted into a couple of strings, and the level 1 text-to-speech.py program is going to pass to the audio driver and to the speaker on board the Scuttle the heading so it can be spoken out loud. So I only need to have the heading declared once every 3 seconds. In other examples, I may want to have messages declared through the speaker, such as obstacle discovered, which can occur due to specific events rather than on a fixed timing. Regardless of the timing of the speaking loop, it takes about 1.5 seconds to say the words out loud. If the speaking event is added inside of the driving loop over here, it will cause a big gap in the speed control executions, and it will cause an interruption of the motors receiving an updated power level. In this case, multi-threading can be used so that both these tasks can be executed in parallel. The ARM processor can handle rapid executions of all functions, and the potential delays are simply due to the time it takes to execute speaking. If you have delays due to heavy processing requirements, multi-threading will not solve your problem. Multi-threading is not a magic tool. Here's how I've set up the level 3 tellheading.py program and the level 3 drive GP program. This one is for driving by the gamepad, and actually for the video that's coming up, I've actually taken out the phi targets that are requested from the gamepad and replaced them with simple constants so my robot will drive in a circle. All of the information, the importing takes place, and then the variables which are initialized outside of the main loop are actually recopied into a program into a function called go. And then the purpose of the go function is to wrap up all of the declarations and functions that I would normally have in the loop of the level 3. And you can see down here the while loop for the level 3 has been commented out, and basically all of this information is put into a function called go. In level 3 tellheading.py, I have the same situation. A switch case is what's generating the north, west, east, south strings that are going to get passed to the audio, and then the function called go is going to do the declaration of the heading via voice, and then it's going to sleep for 3 seconds so that there's a delay and it's not continuously talking. In the level 4, we basically just import both level 3s and we ask them to join the threading. What happens is the importing is here in lines 8 and 9. Then I define a loop speak where I'm simply I'm not actually even going to loop. In this instance, I'm just going to call that function once, and it has an infinite while loop inside of it. The same thing is happening with the loop drive, so I have drive.go. Now, in the main function of my level 4, I'm going to tell you that I'm starting the main function. I'm going to create an object for the threads. I'm going to make my first thread object, and inside that object will be target equals loop speak. So the speaking will be added to this. So then I'm going to append this object to the threads object, and then I'll start this thread. And we're going to print out to the screen that we started the first thread. The same few options are being executed for thread 2, which is going to handle the driving, and then thread 2 is being asked to start. And then finally, lines 36 and 37 refer to the details you should read up on. It's most important if you need to wait for one thread to complete some certain actions before you finish your program, or before you finish operating another thread.
Heading north. Heading north. Heading south. Heading west. Heading north. Heading south.